Hello and welcome to QED Lecture 5 Part 7. Here we come to the two independent samples t-test. It's possibly the most useful simple test, and I think much more useful than the one sample t-test, because in this case you don't need to have this value of mu, the population mean that you're trying to test. It refers instead to the much more common situation of testing the means of two different groups. And we think of these two different groups as two different populations. So what you need is you need two random samples, so a sample from group A and group B. Then the null hypothesis is always just that the mean in group A is the same as the mean in group B, fine. And the alternative, as with the one-sided t-test, as with the one sample t-test, can be two-sided or one-sided. So either you're doing a two-sided one, just testing population means of A and B are equal, so the alternative would be they're not equal, so you're looking for a difference, or you could be looking for a difference one way or the other. So you could be trying to show that population A's got a bigger mean than B, so that would be your alternative, or the population mean is less in A than B, so it would be one-sided the other way. So you've got a two-sided one, or you can have one-sided one in either direction, same as with the one-sample t-test. Great. Now I've put this in purple just to make sure it stands out, that it's different. We really don't assume that you know this stuff in QED, so you can skip over this if you like. It's just here in case people want to know the basis of the tests. And you can just show that if the null hypothesis is true, A and B are equal, then when you start picking a random sample from A and B and doing the sample mean of A minus sample mean of B and getting the difference between them, then the difference between those means, that also has a normal distribution. So if you went through all the possible samples from A, all the possible samples from B, subtracted the means, that follows a normal distribution. And the mean of the normal distribution is 0, not surprisingly, if you think about it. And the standard deviation of that normal distribution, the standard deviation of the means of the differences, is this. So that's, yeah. So these are the sample standard deviations of each subgroup A and B. So you square them, divide by the M1, which the sum, that's how many you've got from B, from A, that's how many you've got from B. So you work out those two things, add them up, square root them, and that's the standard error. And then what you do is you look at the difference between the two sample means. So that's the mean of sample from A, mean of sample from B. Get the difference, work out how many standard errors it is by dividing that, and then from there you just look it up in Excel. But that whole purple page here is just for interest. We will not expect you to know that at all. So let's just jump straight to an example. This is an example from the Dominican Republic. It's carried out, I think, by J. Powell. And they're doing training for microfinance recipients. So often as an addition to microfinance, because you're expecting people to maybe invest the money to either start a business or improve their current business, it's thought it helps to give them some training in accountancy so they can follow the money better and work out how much they have to repay and so on. Standard method is to give them a basic course in accountancy. Then there was a new method which was just some simple 2 or 3 rules of thumb. It doesn't matter exactly what they are, but a much simpler way of doing it. Instead of teaching them kind of double column accountancy using formal methods, there was just a few simple rules of thumb, like check your money once a day or once a week, and check your outgoings once a week, and so on. And then they compared the change in business income. So the change in business income among the people doing the standard method, among the people doing the new method. Okay, so essentially you've got two groups. So it's a randomized control trial. And here are the null and alternative hypotheses. The null is population mean income change in the two groups is the same. The alternative, it's not the same, which means here we're looking for a difference. We're not trying to show that necessarily the simple rules of thumb are better. We're trying to show that it's a difference. So it could be that the standard accounting way is better, or that the rules of thumb one is better. We're just trying to find out if they're not the same. So it's two-sided. So that's written out like this, neatly. So all we need to do is get the data, put this data into Stata, which rhymes nicely. And here's how you do the t-test. So this time it's got this slightly strange by command, which I think we've met before, when basically it carries out this split into these groups. So if you look in the columns here, weekly is the scale variable you're trying to test. So you want to test the difference in this variable, the mean of this, between the two groups. So here's the ones that have the standard training, so it's the mean of those numbers, that number, compared to the mean of these ones where they had the rule of thumb training. So you type that in, And hopefully Stacey will then give you some output like this. And again, you're looking for the challenge for you is just to pick out really the right set of output here. And because we're doing a two-sided one, we're looking for this one. So if the null hypothesis is true, the chance of getting a difference as big as the one we got is 75%. For sharp-eyed people that see that it says equal variances here, it is this calculation, again this is completely optional, this calculation here also assumes that as well as the population means being the same, the spread is the same in each of A and B. So the standard deviation of A and the standard deviation of B are equal. And often that's a very reasonable assumption, because essentially you're assuming that the two subgroups are very similar, except that one's shifted slightly. But if you think that's not a good assumption to make, what you can do is you put on here another option, unequal, just the word unequal here. And that basically does the same calculations with a very slightly different formula. 9 times out of 10, it makes very little difference to the probabilities anyway, so don't get stressed about which one to use. But just if you do see it saying unequal, that's what that means. So we'll carry on with the equal variance assumption. So what we found is this, there's the null alternatives, the p-value is this. So if H0 is true, chance of getting a difference as big as the one we got is about 35%. So what's that going to lead us to conclude? Have a think about this, pause if you need a bit more time. Okay, so I hope you've paused it and had a think about that. Remember, you interpret this in exactly the same way, though it's a different test, exactly the same way as the previous kind of t-test. So you should have come to the conclusion that, because this is quite a high chance, could easily be that H0 is true. If you believe H0, that's true, about 35% chance of getting these results, so you can't reject it. So the data you're seeing is completely compatible with the null hypothesis, because there's a high chance of getting those results. Can't reject it. So this is just writing that down again. Found a p-value of well over 0.1, so you can't reject H0 at any significance level. It doesn't make sense to reject it. So the conclusion would be, for the policymakers and other non-technical readers, that the evidence provides no support for a claim that the two methods of training have a different effect on weekly business earnings. So that would be the conclusion. Okay. Next we're going to a t-test of correlation, but I think I'll put in the next video. So thanks for watching.